Life is motion, and we deal with motion in everyday life. Walking, running, dancing, bicycling, driving, or flying are all activities that involve motion. Today I want to talk about a special type of motion called projectile motion. Studying projectile motion is very important for engineers because projectile motion occurs every day in our life and we want to solve real world problems. Let's consider some of our favorite sports activities. Kicking a soccer ball, throwing a basketball, or hitting a tennis ball. In all these activities, an object is projected into the air. Using a slingshot is another example of projecting an object into the air. In all these examples, as well as other scenarios such as an airplane dropping relief supplies in an emergency situation, we deal with projectile motion. In fact, in a simple scenario, when we just jump, we deal with projectile motion. So, projectile motion involves an object that is projected into the air. An important assumption we make is that the projected object continues its motion by its own inertia, by its own weight, and is influenced only by the force of gravity, nothing else, just gravity. All right? In other words, we want to ignore the effects of air resistance and other factors that may obstruct the motion. So the projectile motion is when the only force acting on an object is the force due to gravity. All right? That's the working definition that we have. With that, let's move on and take a look at some of the kinematic parameters that we deal with in any motion. Motion, the word itself means there is movement from one place to another place, one location to another location. So if there is motion, then there is certain type of displacement. And there is going to be velocity. And there may be acceleration. So these are all the kinematic parameters that are involved in projectile motion. And our goal today is to determine the relationship that involves displacement, velocity, acceleration, as well as the time in projectile motion. All right? Before we move further, in projectile motion, we can project an object into air vertically, horizontally, or at an angle. Let's take an example of each of these scenarios. Here I have a baseball in my hand. I can just throw this ball straight up like this. The ball is a projectile now, and this is projectile motion. In this case, the object is projected into the air with certain initial velocity. It is because of this velocity it is going up. But as it goes up, the ball slows down and the velocity becomes zero at some point in time. And this is the point that corresponds to the maximum height. The ball then starts dropping, right? And it drops and the velocity increases and the velocity is in the opposite direction. So in this case, the body has vertical velocity, positive or negative. There is no horizontal component. Keep in mind the body is moving due to its initial velocity but slowing down due to the gravitational pull. Now let's consider a different scenario. I just dropped this ball and this ball is at rest, meaning there is no initial velocity or the initial velocity is zero, and I just dropped this ball. The initial velocity changes from zero to a higher value and the velocity vector is pointing down. In this case, the ball has only vertical velocity, which is negative. All right? The vertical motion of this projectile in this case is during the free fall. So the acceleration during the free fall is downward acceleration of the acceleration due to gravity. Finally, let's look at the third scenario. We looked at the scenario where we throw the ball up, drop the ball down, and let's take a look at the scenario when we throw the ball at an angle. All right? So we throw the ball at an angle. This is more general form of projectile motion, as you can see, because the body experiences complex motion. It has both vertical and horizontal motion. This means the velocity vector has two components, an x component and a y component. Now, vertical component may be positive or negative depending upon if the motion is up or down. What about the horizontal component? Think about it. Realize we are not considering air resistance. Since there is no air resistance, there is no horizontal acceleration. There is no change in velocity in the horizontal direction, which means the horizontal component of velocity is constant, which means the body or the projected object will continue to have the horizontal component of velocity as it falls down and even when it hits the ground. The famous example for this is when a bullet is dropped or fired at the same time. A bullet goes really fast, maybe 1,500 feet per second. So you can shoot a bullet horizontally, and if you drop a bullet at the same time as you shoot, both bullets will hit the ground at the same time. And that is projectile motion. So, in summary, projectile motion is when the only force acting on the projected object is gravity. That's a very important assumption. In projectile motion, an object may be projected into air vertically, horizontally, or at an angle. And remember, the horizontal component of the velocity is always constant. Only vertical velocity changes. Also remember, there is no horizontal acceleration because the velocity is constant. The vertical acceleration is downward acceleration due to gravity. With this information, now let's go and derive the equations of projectile motion.